Hey everyone, I have another video for you. This one is about how to use CalcPlot3D to look at directional derivatives, and I think it's actually pretty cool. It allows you to do really everything that you would want to do. So here I'm just using our standard paraboloid, x squared plus y squared, and I just used an upper Z clip of 4 to cut this off at the top, so it's just kind of easier to see and doesn't go off the screen or at least out of the box. So here we're going to go to show/hide 2D trace plane, something we've done fairly consistently. And rather than fx or fy trace/tangent line, we're going to show the directional derivative trace. So just going to click this. Notice that it makes my thing a little bit transparent. And I'll just click some random point here. Okay. So it shows several things. I just want to explain all of the things that are involved. The first one I want you to look at is the little green vector. So this is your unit vector in the direction that we care about here. So u is, in this case, 0.71, 0.71. It is basically in the direction along the line y equals x, or the vector 1, 1, something like that, but made a unit vector, so this is 1 over root 2 and 1 over root 2. The reason it's in that direction is it's theta equals 45 degrees or pi over 4 radians. So basically CalcPlot3D can take in an angle and then that specifies your direction vector. Okay, and then it automatically makes it a unit vector for you and will display it as u up here. Then whenever you click your point, the red line here is the gradient of your function at that point. I'll talk a bit more about that when I have a little easier example of points to plug in here in a second. But it has your gradient, and then you can see over here, right, you got your unit vector in green, your gradient down here, and then this is the trace along that direction, and you can see your point, and it's got the tangent line. At that point, we see a somewhat significant positive slope, and our directional derivative duf up here is almost 3, and so that kind of checks out, right? The issue is we're not used to inputting an angle, right? We're used to taking an actual direction vector. Well, the nice thing is CalcPlot3D handles that just fine. You can go to that drop-down menu, go right below the show directional derivative trace, and enter a direction vector. So I'm going to enter 3, 4, mostly because it's length 5, and so I don't have any super weird decimals because I'm just dividing these by 5 when I make it a unit vector. So I'll just hit OK here. And there's my unit vector. So it has coordinates 0.6 and 0.8. That's 3/5 and 4/5. So that's where that's coming from. And then let's look at a few different points here. So if I make x1 and y 0, then first of all, I want to point out, since my function for my surface is x squared plus y squared, my gradient is 2x comma 2y. So here my gradient would be 2 comma 0, and that's exactly this vector in red, 2 comma 0. And so here I have an acute angle between my direction vector and my gradient. I should see a positive directional derivative, and I do. I get 1.2, I have a positive slope, and we can see if we kind of go in the direction of the green arrow, but from our point, right? So notice this black tangent line is kind of pointing in the same direction as the green, but it's just kind of parallel to it. We see a positive slope there. Now, if I make that angle smaller, right? So if I increase my y but keep my x the same, like 0.25, then I should increase, and I do, right? 1.2 to 1.6. If I go up to 0.5, that's not 0.5. I don't know what just happened. 0.5. Then I go up to 2. So I'm getting steeper slopes here the closer I get my direction vector and my gradient. And then it should be greatest, right, if I have my direction vector and gradient in the same direction, because I know that the direction of steepest ascent is my gradient. So in order to have this stay on the paraboloid, I'm going to take 1/2 of each value. So the direction vector was 3, 4. So I'll just make this 1.5, 2. And I have to zoom out a little bit to get 6.25. But then first, look over here in the 2D. Notice that my direction vector and gradient are literally along the same line, so it's the same direction. And over here, I can see that slope is quite steep here, and I got the value of 5. So my rate of change is 5. I go up 5 for every unit I move in this direction. Okay, so that's some stuff you can do. So obviously it's nice in that you can literally see your unit vector, you can see your gradient, and you can actually get the value of the directional derivative. It kind of shows you everything you would need to know for directional derivative stuff in CalcPlot3D. All right, that's all I've got.